Hello everyone, welcome to this video. After a very long time I'm creating this video. I did not get a time in this span. I had the exams on. So in this video we are going to discuss about the first chapter of ISC 11 chemistry, that is some basic concepts of chemistry. Today's video is going to be the light one, okay? The main portions are coming up in the next videos, okay? Today is the introduction of what is chemistry and certain portion of significant figures and all that, okay? So let's begin. We are studying right now which subject? We are studying the subject chemistry, right? We are studying the subject chemistry. So when we are studying the subject chemistry, we should also know what exactly is chemistry, right? What is chemistry? No one asked you this question. What is chemistry? We had chemistry, so we are studying chemistry. What is chemistry? Chemistry is a science, a branch of science, not actually a science, it's a branch of science which mainly deals with colors. Now this is colors of life, okay, not that color you see, it's color of life. Another one is it's rasas, clear? That's why in Bengali we'll find chemistry being said as Rasayan Shastra. In Hindi also it is Rasayan Shastra, okay. Physics is Padartha Vidya, so that is all that. I'm not going to physics now. Chemistry is the study of colors and rasas, different types of rasas which make up our life, okay. Now if you have read that ancient Vedic literature and all that you had in history, you have learnt about the Panch Tattva, right? The 5 elements of nature. You have is your Akash, you have is your Jal, you have is your Vayu, you have is your Agni, and you have is your Prithvi. The 5 elements of nature, right? Learn that. Now what we are classifying is the different ages of chemistry, okay. Approach to chemistry was made long back, even when in that Vedic period also there were approach to chemistry, okay. But we'll not be studying from the Vedic age definitely. So first attempt to chemistry was made between 350 to around 1580. This is not very necessary, okay, because generally questions do not come up from this part. This part is just kind of introduction part, okay. So here I have not learnt about alchemists. Alchemistry was the part from where chemistry originated, right? So during this time alchemists were searching for two things. First one is a philosopher's stone, not Harry Potter and philosopher's stone, please, okay. This is philosopher's stone, and another one was nectar, not that nectar which you are thinking, okay. What is philosopher's stone? It was believed that there was a stone which could make metals into gold, or which could convert metals into gold. That was philosopher's stone. Is it really possible? It's not possible. No one got it. No, alchemistry is generally concerned with converting a metal into gold. Is it possible? No one succeeded, right? Then we have this nectar. What is nectar? It was again a hypothetical syrup that was believed to convert a man into its youth and make him immortal. Is it again not possible? Because no one is immortal. Everyone is a mortal one, right? So this is a hypothetical syrup, and this one is a stone which would convert metals into gold. Done. So this was the period from 350 to 1500 AD. Following this period we have is the iatrochemistry period. Which period? Iatrochemistry period. That's not in very details. We have the iatrochemistry period. This period we come to see about Boyle's law. Robert Boyle, scientist who gave up the Boyle's law, was a scientist of this period. This period was generally around 150 to 1600, okay. In this time Boyle gave his famous law, Boyle's law. Understood? Clear? Then after this period we come to his phlogiston period. Phlogiston period. This period is an important period. Phlogiston period. Okay, years are not at all important because this is not history where years will come up in your questions. So this is phlogiston period, around 1650 to 1774 AD was this period. Now in this period we come to see about a scientist known as Ernest Stahl. Who? Ernest Stahl. he put up a controversial theory which was called phlogiston theory. Okay, if the spelling is sounding difficult, remember it as pH phlogiston theory. Okay, I personally remember it as pH phlogiston theory, but pronunciation will be very awkward, so I am saying it as phlogiston. Okay, so phlogiston period, we come to see Ernest Stahl, a scientist who will put up a controversial theory called phlogiston theory. What does it state? According to the phlogiston theory, the substances which contain phlogiston are phlogisticated substance. Okay, and when they are burnt, they dephlogisticate, that releasing the phlogisticated substance out in the air, which is again absorbed by the air. This is a controversial theory, completely controversial theory. Okay, what does it say? I am repeating again. According to this theory, phlogisticated substances, they contain phlogiston in them. When they are burnt, this phlogiston escapes into the air, which is absorbed by the air. Done. So the substance becomes dephlogisticated. Okay, this was the phlogiston period. Following the phlogiston period is the current period what we are undergoing through. It is the modern period. Every subject has a modern period. Even modern physics is there. Radioactivity, you have learned in physics, right? So this is the modern chemistry or modern period of chemistry. All the things that have happened is in all the modern period of chemistry. Okay, 18th century. After 18th century, it is everything modern period. What happened? Firstly, you have is your Priestley. Forgive if the spelling is wrong. I am not very sure about the spelling. Okay, Priestley discovered oxygen. Then comes father of chemistry. Who is the father of chemistry? Father of chemistry said that yes, oxygen is okay. He confirmed Priestley's discovery. Who is the father of chemistry? Answer in the comment section. Who is the father of chemistry? Okay. Then he also added on that this gas is required for combustion. Okay, all these are falling under the modern period. Point wise they will be noting it down. Okay, first point will be that Priestley, discovered, not invented. This is not an invention, this is a discovery. So discovered oxygen gas. Father of chemistry, who is it? We will write the name and we will write confirmed the discovery of Priestley and also said that oxygen gas is needed for combustion. Done. Then we come to see John Dalton. I am writing Dalton only. Okay, Dalton. What did Dalton do? He put forward his atomic theory. So Dalton put forward the atomic theory. Here comes his 1803. Okay. Then we come to see is Mendeleev. What did Mendeleev do? Mendeleev, he put forward his periodic table. Here is 1869. Then we come to see about Faraday, Michael Faraday. He studied the passage of currents through solutions. Clear? 1833. Then we come to see, here's a not actually I have not also written in the order. Okay. Arrhenius. Then we come to see Arrhenius, theory of electrolytic dissociation. Arrhenius, he proposed his theory. Then we come to see Thomson, J.J. Thomson. Is the spelling consist of P? I'm not sure about that again. Okay, I don't think it consists of P. Let's write like this one. Yeah, Thomson. Clear? Thomson, what did he do? He found out the subatomic particle electron. Then comes Goldstein. Goldstein found out proton. Then comes Chadwick. What did he do? He found out neutron. Then comes Rutherford. What did he do? He also had a great hand in finding out the radioactive rays, and in chemistry it's the nucleus. Okay, but do not ignore him in the radioactive rays that you are reading in case of physics, Becquerel rays. Okay, then we are coming to last one, Moseley, Henry Moseley. What did he do? Modern periodic law. Atomic number is the fundamental property, right? So advent of atomic number was done by Henry Moseley. So all these things come under the modern period of chemistry. Priestley invents or discovers. Priestley discovers oxygen. Father of chemistry confirms that it's oxygen. also states that oxygen is required for combustion. Then Dalton put forward his atomic theory. Mendeleev put forward his periodic table model. Faraday studies the passage of current through solutions. Arrhenius proposes his theory of electrolytic dissociation. Thomson discovers electron. Goldstein discovers proton. Chadwick discovers neutron. Rutherford discovers nucleus and also has a great hand in discovery of Becquerel rays. Or rather, we will say study of Becquerel rays. Okay, mostly advent of atomic number, because he was the one who said that atomic number was the fundamental property. Because this person Mendeleev, he said atomic mass, but isotope will come into play. Okay, done. These are the periods of chemistry that we are learning as of yet. Now we'll move on to the next part, that is branches of chemistry. Branches. Just we need to know about the branches. Okay, you already know about the branches. You have 3 branches in your syllabus. First one you are learning right now, it's physical chemistry. Number 2 you have is inorganic chemistry. Number 3 is organic chemistry. You have other branches as well: analytical chemistry, chemical physics, industrial chemistry, pharmaceutical chemistry, biochemistry. So lot of other branches are also there. Even agricultural chemistry is there. What is inorganic chemistry? Inorganic chemistry is the branch of chemistry that deals with all other compounds except those of organic nature. Very simple. What is organic chemistry then? Organic chemistry is the branch of chemistry that deals with the compounds containing carbon. It can be aliphatic hydrocarbons and derivatives, it can be carbohydrate, protein, that's under the biomolecules again. All those things are read under organic chemistry. Even benzene derivatives are read under organic chemistry. Then comes physical chemistry. Physical chemistry is to everything we are giving a logical relation with the help of, can it be hypothesis, it can be theories, laws, whatever, but you are providing a logical reasoning. Clear? Logical explanation. Done. Next is analytical chemistry. You already have done analytical chemistry. Qualitative, quantitative relationship. It can be analysis of a salt, liquid, gaseous mixture. Clear? Biochemistry is application of chemistry to biological systems. Done. Chemical physics is the study of chemistry of physics, not physics, exactly not physics, it's physical systems. Clear? Physical systems like plasma. Okay, do not write study of physics. Okay, then industrial chemistry, by the name you can understand, application of chemistry in industries. Done. Agriculture, in the development of seeds, fertilizer, agricultural chemistry. Pharmaceutical chemistry, drugs, prevention of various diseases, use medicines, they have drugs. All the things are related to chemistry. That's pharmacy, a different branch is there, pharmacy. Okay, some life-saving drugs names have been mentioned in your book: cisplatin, Taxol, azithromycin. Okay, I don't know a lot of biology, so don't ask me what are these now. Okay, now next we are going for the different classification of matter. Now universe, this universe we have, you know, universe is classified into 2 things. One is your mass, one is your energy. These 2 things make up this entire universe. What is mass? You already know, something that occupies space and has got a definite mass is a matter. Clear? Matter. Understood? Clear? Now instead of writing this mass, I can put a better word that I just now said, matter. So we are not going to use mass, we are going to use matter, because we know E equals to mc square. So people will put mass energy. It's not actually correct. Okay, so what we will be writing? We will be writing matter, because matter best defines mass. Mass, anything that has mass and occupies space, is matter. So what is matter of the universe? Only mass? No. So matter and energy. What is matter? Definition of matter you already know. Done. Next, this matter, energy we'll discuss later on. Okay, matter, we have classified it into 2 types. First type, physical classification of matter, chemical classification of matter. Now I will not be discussing about physical chemical classification in a very details. I just say you the overall look. If you are classifying in physically, then you have got a solid state, liquid state, gaseous state. 1,000 times you have studied about what are this, so I am not going into any details about this. Then you have this chemical classification of matter, which is basically pure substance and impure substance. You already know what is a pure substance. Element, compound, mixture, or impure substance is a mixture. That's homogeneous mixture or heterogeneous mixture, right? What is an element? You already know, nothing to say. What is a compound? You already know. What is a heterogeneous mixture? What is a homogeneous mixture? Everything you have already discussed. Elements classified into metals, non-metal, metalloid. Okay, these I am not discussing because you have already read it in your junior class. Done. Next, compound will be classified into two types: inorganic, organic compound. Again, the same logic applies over here. Living source organic, non-living source is it inorganic. Done. Mixture understood. Okay. Now we are moving on to properties of matter. Homogeneous mixture, you already know, all particles will mix uniformly. Heterogeneous, not uniformly mixed. Simple. Done. Next we have is properties of matter. Properties of matter. Again, there's two properties of matter. One is a physical property, one is the chemical property. Physical property, understand this. Physical property is a property which you can measure, without any change in the identity of the substance. Physical property is a property which you can measure without altering the identity of the substance. That is a physical property. What's the chemical property? Chemical property are the properties which require a change, which require a chemical change and involve a change in the chemical composition of a substance. Clear? Understood? So that is a chemical property. Next we are coming to our new concept, not actually a new concept, it's, you already know what is it, but we are still reading it. It's called measurement. It's called measurement. Now physical chemistry, as I already said, gives logical explanation to whatever is happening with the help of theories, with the help of hypothesis. So there will be numericals. It's the physical chemistry, right? So we have to do measurements. We have to, in analytical chemistry, do qualitative and quantitative analysis and all that. You have is measurement. What is measurement? You measure something, you take what is this, what is that, that is measurement. So measurement, we need a particular system of measurement, right? We need a particular system of measurement. Measurement should be in terms of a unit. Like what are we measuring? How is that? If I write randomly 1, 2, 3, 4, 15, 21, what are these? We don't know what are these. So we need some unit, right? If we write 1 gram, we'll understand it's a weight. If we write 2 meter, we'll understand it's a distance. If we write 3 seconds, we'll understand it's a time. If we write 4 degrees Celsius, it's the temperature. If we write 21 mole, amount of substance. So we need to put a proper unit. Otherwise, what will we understand what the value is, right? So this is measurement. So this unit we use is a metric system. Metric system. Do you remember in physics you have read metric system, introduced by the French Academy of Science. French Academy of Science, the first system was metric system. This system was introduced by French Academy of Science. It is a decimal system and every unit is related by the power of 10. By the power of 10, every unit of a physical quantity is related. Clear? But this was later on not considered. Final we come to see is your SI unit. This is what we are going to use. The General Conference of Weights adopted the International System of Units, that is SI unit. This system is popularly known as SI system. It is a French language, Les System International de Units. We say it as SI unit. Now whatever we are going to do, we have to put the proper SI unit in the numericals. Clear? Understood? Now we are moving on to a term that you already have read in physics thousands of times. That's a physical quantity. Any quantity that can be measured is a physical quantity. Do you remember in physics? Any quantity that can be measured is a physical quantity. Now we are not doing physics, so we will not go to derive physical quantities and all that, right? Independent physical quantities and derived physical quantities. We are not going to go to that. And what will we do? We will be studying about two types of variables under this physical quantity. Okay, first one is a discrete variable. Number one is a discrete variable. Okay, discrete variable. What did I write? Discrete variable. Discrete variable means the quantities which can be measured with certainty. Discrete mane asbe certain. I am certain about something. So it's certainty. Clear? Certainty. Dexter. Certainty. Clear? The quantities which can be measured with certainty, it is called discrete variable. Suppose I have here two chalks. I am certain I have two chalks. Definitely there are not many more chalks because I can see two chalks are there. Right? So I am certain. So this is a discrete variable. Understood? Clear? Now the opposite of discrete variable is a continuous variable. What type of variable? Continuous variable. Continuous variable. This means uncertainty. Please, uncertainty principle has not yet come. Okay? It's uncertainty. Uncertainty means measurement. There will be some uncertainty in the measurement. That is continuous variable. Clear? Quantity that will involve some uncertainty in the measurement has to be a continuous variable. Clear? You cannot measure this with perfectly. Perfectly though you cannot measure only. You can measure with great accuracy and high precision. What is precision and accuracy? I am coming later on. Clear? So here, with how much precision can you measure this particular quantity depends upon the accuracy of the instrument you are using. Okay, I have used two terms, precision and accuracy. What's that? I am coming to it. Okay. Okay, suppose if we want to measure a weight of a mango, a choto mango, by the balance of a fruit vendor, then it can be measured by 50 gram. Suppose the vendor has a 50 gram, like we will just considering it, so 50 gram, maximum it can be 50 gram. But if you are going to a larger shop, maybe he has more. It can be measured with accuracy of 10 gram. Understood? Clear? This is uncertainty. Always there is an uncertainty. Clear? Done? Now I have used two terms, accuracy and precision. What are these two? You already have come across the term accuracy and precision. I think in your life. Precision you might not have come, but accuracy definitely you have come. Accuracy. Accuracy means how close is your value. How close is your experimental value to the true value. Accuracy is how much is my value, my experimental value close to the true value. So accuracy you can find out by true value minus experimental value. Did you understand it? You can find out accuracy by experimental value, mean experimental value. Oh, sorry, not true value minus this. Sorry, reverse. Experimental value minus true value. Okay, now whenever you take experimental values, do we take only one value? Might be there is an error. What do we take? Always physics, mean. So there will be a mean experimental value minus the true value, that will give you the accuracy. Clear? That will give you the accuracy. Now, if accuracy is more, then this difference has to be the less. Understand? Understand this. If your accuracy has to increase, then your mean experimental value has to go closer to the true value. So your difference will automatically fall down. But if your accuracy is less, that means your experimental value and the true value is far away from each other. So your accuracy level is down. Did you understand? So what is the meaning of accuracy? To what extent is my experimental value close to that of the true value? This is called accuracy. So we will write the definition. If asked, accuracy is the extent to which experimental value is close to the true value. You can find it by using this formula, mean experimental value minus true value. Clear? Smaller the difference, greater the accuracy. Okay, if accuracy rate will increase, that means your experimental value is closer to the true value. So your difference will automatically fall down. Understood or not understood? This was accuracy. Clear? Do not get confused. Accuracy done. Now we are moving on to the second term that I used, that is precision. Second term that I used, that is precision. Precision is basically closeness of values that you have measured. Did you understand? Precision is not related with the true value, it's the closeness of the values that you have measured. It means closeness between the experimental values. Understood? It's not with the true value, it's closeness between the measurements of a quantity. Of a one quantity, different measurements you are taking 3 to 4 times. What is the closeness among them? That is your precision. Clear? But accuracy is with the true value. What is your extent of closeness? Okay, understood? Okay. Okay. Now suppose you have a weighing balance. Drawing is very bad. Therefore, this is a weighing balance. Does not look like though. You have kept here a weight of, let us take 50 gram, and you have kept here, let us take a ball, right? This is a weight like this. Let us take that. Though it does not look like, actually it's like triangular. It should not be triangular. Wait, let me make the diagram more proper. Otherwise, it will hurt your brain. Wait. If like this, just understand. Okay, though it does not look like even. Okay. So suppose here is 50 gram weight and here is this. What happens is, you see that this side slides down and this side goes up, right? That means this side is heavier. Clearly understood that this side is heavier. Fine. Suppose you get the measurement of this is as, let us take as 30.0 gram. Fine, 30.0 gram. Very good, congratulations. Now the moment you change this to 10 gram, or let us take 100 gram, more up it will go. Very good. At that time you measure, you will get around maybe 30, or I am taking 30, but you will get 30.234. No, this is not possible. 265 grams. Suppose you are getting this. Clear? So the last digit you see this, previously it was 30.0, that was uncertain. Here also this 5 is uncertain. You will increase this again, you will find again something has entered over there. So the last digit of this value, any measurement last value is always uncertain. You do not know whether it will be sure or it will be changing. It will be changing. Like here it was 0, now it changed to this. Clear? So the last digit of a measurement is always uncertain. Clear? Rest of the digits are certain. These digits are certain, but last digit is uncertain. Clear? Understood? Last digit is always uncertain of a measurement. Other digits are certain. So a measured quantity will include digits which are certain. Last digit will be uncertain. Clear? With this concept, let us move on to a complete different concept that you call as significant figures. Clear? Significant figures. What is it? Significant figure is total number of digits in a measured quantity. It is called significant figures. What is the total number of digits present? It is significant digit. Now, total number of digits, you have everything present. That also will not work. You have to abide by some rules. So you can neither add all the digits, neither can you leave out any digit. You have to follow the rules and then do whatever you need to do accordingly. Right? So we'll discuss the rules. Hold on. Okay. Significant figures, as I've already told, it's the total number of digits present in a number. Suppose I write 12. What is the number of significant figure? We do not know. We do not know. Why? Because the last number is uncertain. So how can we say how many significant digits are there? This is again a concept that you will be using when you are going to solve 12 into something divided by something. You have these basic calculations. You don't have to do in calculator definitely. Then I will tell you again that a whole number is having an infinite number of significant digits. Okay, whole number is having infinite number of significant digits. Please note it down. Whole number has infinite number of significant digits. Whole number has infinite number of significant digits. Infinite number of significant digits. Clear or not clear? Why? Reason is very simple. Last digit of the number is uncertain. So how can we say how many are there? Because it will be changing. We do not know how many are there. So for a whole number, it is always infinity. Okay, clear? Number is infinite. So this is clear? Understood? A whole number will have infinite number of significant figures. Now we are moving on to the rules for significant figures. The rule for determining the number of significant figure. Rule number 1. Rule number 1. Any number which is not 0, any number not equal to 0, comma, is a significant number. Significant number. Okay, this is a sign of not equal to. Clear? Any number which is not equal to 0 or non-zero number is a significant number. So if I write 1, 2.0, how many significant numbers? 2. 2. Now it is 2 because the last digit is about this. This one is the last digit. That is uncertain. Clear? Okay. Number 2. Rule number 2 states that all the zeros placed to the left, understand, any zero placed to the left of first non-zero number, first non-zero number is not significant. Did you understand? Not significant. What do I mean? If I am placing a 0 in front of the first non-zero number, this 0, this is a non-significant number. Clear? So how many significant digits? 3. 4 is not the correct answer. If you are placing any 0 before the first non-zero digit, it is not considered significant. Understood or not understood? Understood or not understood? Third rule is in complete contrast. Please see it properly. Please see it properly. Zeros placed after decimal are very much significant. Are significant. Zeros placed after the decimal are significant. Clear or not clear? Right of the decimal point, not only after the decimal point, to the right of the decimal point, any 0 is significant. Right? What do I mean? 12.0 significant. Clear? 12.0 is significant. Alright, like these numbers will be there, that will be significant. Alright, understood? So any 0 placed to the right of the decimal point is significant. Done, but a whole number has infinite number of significant figures. Number 4. Number 4 is the last one. Zeros placed between. 0 placed between two non-zero digits is very much significant. Clear? Zeros placed between two non-zero digits is very much significant. Suppose the number is 1.008 mass of hydrogen, that is 4. Clear? 4 significant digits here, right? This is the mass of hydrogen, 1.008. Okay, so these are the 4 rules to keep in mind. First rule is whole number will have infinite number. It's not actually a rule, just a thing to note down. Whole number will have infinite number of significant figure. All zeros placed to the right of the decimal point will be significant. Any zero placed to the left of the first non-digit number will be not significant. All non-zeros digits will be significant. And number 4, zero placed in between two non-zero digits will be significant. Clear or not clear? These are the 4 rules which you will be reading to keep in mind when you do this numericals. These are basic numericals. I will just do the numericals few once. Okay. Now we come to another topic, exponential notation. Exponential notation. What do we write is? Suppose we have is 2. Let us take 3, 3, 6, 0, 0, 0. What is this? Specific latent heat of fusion of ice. Instead of writing so many zeros over here, we can write it as 3.36 into how many zeros? 3 zeros. How many decimal point? 2. So power added. So how much is coming? 3.36 into 10 to the power 5. You multiply it, you will get 3 zeros behind. 2 zeros will be due to the point. So instead of writing this, we are writing this. Now you say, how many significant digits are here? Infinite. We do not know how many are there, but how many are here? 3. So what is the significant digit of an exponential notation? It's the constant number that you see. Constant number, that is this value. Clear? Here we did not know how many, but here we knew 3. Because there is 1 to the power, that we are not going to consider. We are going to consider 3.36 as your answer. Clear or not clear? Clear or not clear? Clear or not clear? Now, if you rewind the video, you will get, I have told somewhere 12 and 12.0. There, just make one correction. 12 has infinite number, but 12.0 will have 3. Why? Point after decimal point, whatever 0 is there, it is significant. Whole number it is told. If you write decimal, why, how will it become a whole number? It becomes a decimal number, right? So whole number will have infinite number, but point something is significant, so it will have 3. Clear? Exponential notation understood? So when exponential notation is there, how will you take it out? The constant value is the answer. Okay, now let's do a tuk-tak small sum. Take it out from your book, what is given. Let us pick up one sum and do. You have is here. Okay, it is told 0. Estimation you all know. Estimation, if it is greater than 0.5, you add up 1. Right, you already know that. If it is greater than 0.5, you add up 1. Right, estimation notation, you already know that. Great. Okay. Let us pick up one sum. Wait, let me find out one sum. Okay, let's do this. 0.006756. It is told round, not round, it is told express this in 3 significant digits. See, right? Yes, express this number up to 3 significant digits. How will you express it? Try it out. Express this number in 3 significant digits. How will you do it? Try it out. Pause the video and try it out. How will you express this number in 3 significant digits? Now I am solving it. 3 significant digits means how much we need? We need these 3 values. Why not these 3 values? Reason is the third rule. Third rule or second rule? Second rule. All zeros to the right of the first non-zero number is not significant. So this is right now. which are not significant. So you have is only this 3. Right, now you will say after decimal point this is also significant, but that is the condition later on. What is the first condition? All non-zero digits are significant. Done. Correct, those are significant. Second rule, what was that? 0 substituting the first non-zero digit is not significant. Following that is after decimal is significant. So these zeros are not significant. Done. So it is 0.00. Why will you ignore it? You have to ignore it, but you cannot remove it, right? If you write 0.676, is it correct? Not correct. This is wrong. You cannot write that, right? So 0.067, done. So this is expressed up to 3 significant digits. Clear? This is how you doing it. Okay. Another one, you take it out. Express the following up to 3 significant figures. Take it take it let me check. Okay, 3.769. How will you express this? 3.769. How will you express it? In 3 significant figures. Express it up to 3 significant figure. What will be the answer? What is going to be the answer? Check it out. I am doing it. We need 3. So we need this 3, not this 3, this 3. So 3.77. Clear? You have to just round up this value particular. Greater than 5, rounded up to 1. Understood or not understood? Done? Now we are coming to one important thing and the last topic for this video. That is how you are going to add up and subtract and multiply, divide significant figures with relation to significant figures. Clear? Okay. Calculations involving significant figure, you will find it in your book. Under that we are going to do subtraction, addition and division. Okay. Suppose I have a number 1.008. Very good. I have another number 0.0729. I have another number 0.08. If I add up them, you can use your calculators. In 11 it's allowed. So let's put it on the calculator and check it out. What's the answer? 1.008 plus 0.729 plus 0.08. Added up, answer shows 1.817. After addition, okay, add. You have got this answer. Now when you add up, you will be putting your answer to the same number of decimal places, not my words, decimal place as present in the quantity with the least number of decimal place. Which quantity has the least number of decimal place? How many decimal place here? 3. How many over here? 4. How many over here? 2. So how will you report your answer to? 1.81. Clear or not clear? This type of questions might be asked. Add up this. You might feel it's a very stupid question, but you have to apply the rule. When you are adding or subtracting, your answer should be reported to the same number of decimal places as present in the quantity having the minimum number of decimal place. So if you leave your answer here, here goes your answer wrong. So the magnitude of your answer or the value of your answer is correct, but your estimation is not correct. Clear or not clear? Understood or not understood? Now if I subtract this, you will get is 0.199. I hope I am correct. Let me check once again. 1.008 minus 0.0729 minus 0.08. No, wrong. That is what I was thinking. We are getting is 0.8551. Fine. Again, you see how many digits here? 4 after decimal. Here we need 2. So you have to round this off. So 0.85 will be your answer. Now we'll say, sir, 5 is there, why have not increased it? No. According to the chemistry, it's greater than 5. Digit will be increased by 1, else it will be retained. Clear? So it's equal to 5 will not increase. Equal greater than 5 will increase. Okay. Understand? Okay. Okay. So this is addition subtraction. We will be reporting it to the least number of decimal places that is present in the quantity having the minimum number of decimal places. Done? This was add and subtraction. Now we are moving on to multiplication and division. Now you say what's the difference? Difference is there. Multiply 1.008 comma 0.729 and you will multiply is 0.08. Probably perhaps I gave it 0.079. Same number I have given. Now you have to multiply. So let's multiply and check what is the answer. 1.008 into 0.0729 into 0.08. Answer is 5.878656 into 10 to the power minus 3. I am least bothered about this. I am not bothered. What we will do, what we have to do is, we have to round off our answer to the least precise quantities, number of significant figures. Okay. Who has the least number of significant figures? Who has the least number of significant figures? This person. How many? 1. This person has 3. This person has 1, 2, 3, 4. Who has least? How many? 1. So we have to report this answer to one significant figure. That means we have to retain only this value. Right, but you cannot retain it 5. As you can see, all are greater than 5. Except this, all are greater than 5. So you have to add up. So let's check. 5 point. This 6 will add up to this. This will become 6. Again, this will make it 7. Let us do step by step. 8, 7, 8, 6, 6. Done. Then 8, 7, 8. This 6 will make this 6, 7. Then 5.879. Then 5.88. Then 5.8. No, sorry, 5.9. Finally, your answer is 6. So your answer is 6 into 10 to the power minus 3. Understood or not understood? This is the answer. 6 made this 6 written. Remove this 6. This 6. Oh. This is what you do. When you do errors, this is how you do errors. Okay. 5.878656 into 10 to the power minus. This part I am least bothered, but you cannot omit it. Okay. Okay, now see properly. Even I need to see properly. This 6 is making this guy 6. So 8, 7, 8, 6, 6. This 6 will not write again. Next step, this 6 is making this guy 7. So 8, 7, 8, 7. 2, 8, 7, 8, 7. This one step, this error came up. We wrote 6 again. Okay, 5.8789. 5.88. 5.9. Next step is 6. So 6 into 10 to the power minus. So answer is same. Coincidentally this became same. Clear? So this 6 made this person 6 written. This 6 made this person 7 written. This person made this 9 written. This person made this 8 written. 8 written. 8 made this 9 written. 9 made this 6 written. Clear? So final answer is 6 into 10 to the power minus 3. So what will your answer? This one. How many significant digit? 1. How many significant digit over here? 1. Same will happen if you divide it. Okay. In division also, your answer has to be reported to the least number of significant digits present in the least precise quantity. Clear or not clear? But I am not showing the divide because it's the same procedure you have to apply. Okay, understood? So in case of addition and subtraction, you report your answer to the least number of decimal places. And here it is least number of significant figures. Now let's pick up some sums from your book. 1 or 2 sums let us do. Okay, let's take this sum. 14.6 into 313.756 divided by 12. Okay, divided by 12. Alright. You have to report the answer. You have to express the answer with a proper number of significant digits. So pick up your calculators, put it on the calculator, check the value 313.756. Answer got divided by 12. You are getting the answer as 381.73646667. Okay. What we have done? We have done multiplication division. So we need to report it to the least number of quantities, least number of significant figure. So how many least significant? Let's see. This 2 we cannot take. This is whole number. How many over 1, 2, 3, 4, 5? They cannot take. This is 3. So we need 3. So 3 means only this part. So what will be? Let us take. If you go from here, this will become more. Okay. So you can take up to this also. Okay. So it can become 381.7. 381.8. Next step it will become 382, because this you can take everything now. If you take everything also, you see this will become 7, this will make this 7, this will make this 7, this will make this 5, this will remain 5, this will remain 6, this will make this 3, this will make this same. The answer will again come same. Clear? But this is just short procedure. If you want to apply direct procedure, you go for direct procedure. No one has stopped you. Clear or not clear? So answer is a long one. I am taking up to 2 decimal places or 3 maybe. 381.74, 381.7, that is 382. So required answer is 382. Clear or not clear? Required answer is 382. So what you have to do? You have to just check the question, put the proper values on the calculator, recall what the rules are for significant figure, for addition, multiplication, division, subtraction, what are the rules, and just apply the rules here. So that's all what we have studied in this video. In the next video, we'll be moving on to the next part of the chapter. So see you all in the next video, and hope you have enjoyed watching this video, the first chapter of SPCOC chemistry.